Hi everyone! In this video I'm going to show you how to factor some of the trickier factoring questions where your first step is common factoring. So I assigned questions 13 and 15, so I'm going to show you questions 14 and 16, just so I'm not doing the exact questions you should be practicing, but they're essentially the same steps. Now, the trick for these ones, 27 times 108 is, huge. It's like, 2,800 something. Like, I don't want to deal with that. So the good news is I don't have to because there's a common factor of 3. So this means that 27, 255, and 108 are all divisible by 3. And sure enough, 27 divided by 3 is 9m squared. I know that 80 times 3 is 240. So 240 plus 15 would be another 5. So this is going to be 85 if you followed my mental math. If not, well, you could use a calculator or whatever. Regardless, when you common factor a 3, you're going to get 9, 85, and 36. And those numbers are big, but they're not ridiculously huge. And as we set up our diamond puzzle, you'll see that the numbers actually don't end up being that huge. Okay, so the way we fill this out, our middle term is our sum. So that's going to be negative 85. And then we're going to take our first and our last number, multiply those together. So 10 times 36 will be 360. So 9 times 36 is going to be 36 less than that, which is 324. So now I need to come up with two numbers that multiply to 324 that add to negative 85. So that's not super obvious, but we can sort of work our way through. 1 times 324 is our basic factors. That's just, 1 times a number is always fine. 2 is going to go in, so half of 32 is 16, and half of 4 is 2, so 2 and 1, 62. 3 goes in, and 3 is not too bad, because 3 divided by 3 is 1, and 24 divided by 3 is 8, so that's 3 and 108. And as we're going through, I'm sort of mentally checking, am I close to getting a sum of 85? And it's negative 85, so they're both going to be negative numbers, but whatever. I need two numbers that are going to give me 85. The number here with 2 is divisible by 2, so that means I can get another factor of 2 out of it. And if I take a factor of 2 out of 162, I get 81. And sure enough, 4 and 81 is 85. So my numbers are negative 4 and negative 85. Now I like a box method, so I'm going to set up my box method for my factoring. Now, I'm only going to do my blue polynomial, right? The 3 in front is already factored, so I don't need to worry about it. So this is minus 85m plus 36. Now, the 9m squared goes here, the 36 goes here, and those two numbers I just found, the negative 4 and negative 85, they're the ones that go here. Or sorry, not 85, what am I saying? Oh my goodness. 81. That number is an 81, not an 85. Okay, sorry about that mistake. So that's 81. So we're going to common factor up here. 9 and 4 have nothing in common, so it's just going to be m. And if that's m, then this has to be 9m, because m times 9m gives me my 9m squared. So positive times a negative is 81, positive and negative 9, and negative 9 times m gives us just m. And negative 9 times negative 4 gives me positive 36. And as a check, is negative 4 times m negative 4m? It sure is. So there you have it. There's your factored form. So this equals 3, m minus 9, and 9m minus 4. Okay, so now this next one. Now 364 and 360 have a difference of 4. And so that tells me that 4 is the biggest possible common factor they could have. And sure enough, it is 4. So if you pull a 4 out of this, you're going to get 9x squared negative 91x plus 90. Now again, 9 times 90 seems like a really big number, but this one actually works out really nicely for us. When we set up our diamond puzzle, we're going to get our sum is negative 91. And our product is 9 times 90. Well, 10 times 90 is 900. So this is going to be 810. Now, how am I going to get negative 91 from 810? Well, the obvious factors for 810, like sort of the one that I would do if I was prime factoring this, I would just split that into 10 and 81 because it ends in a 0. And sure enough, negative 10 and negative 81 are two numbers. And so, I mean, it looked a little bit ugly, but it ended up working out really nicely for us. So we can set up another diamond puzzle over here. And we're going to have our two numbers are negative 10x and negative 81x. And the first thing we're filling in here is our 9x squared. And the thing we're filling in down here is our 90. And just to make sure that I did this correctly, let me just fill in my diagonals. Is this 9x squared minus 91x plus 90? It sure is. Now, I guess I will common factor up the left-hand side again, because that's just what I've normally done. Oh, the way I picked my numbers... Actually, I don't like this. The way I picked this, there's no common factor here. And I just want to show you that it can be... We can common factor here sometimes. So I'm just going to switch these two numbers just to show you that the order you put those numbers might make a difference. And in this case, I'm going to get a common factor of x, and 9 and 81 have a common factor of 9. Now let's fill in the rest of our boxes. So 9x times x is 9x squared. Negative 10 times x is negative 10x. Negative 10 times negative 9 is positive 90. And as a check, is negative 9 times positive 9x negative 81x? It sure is. And so my factored form is 4, 9x minus 10, and x minus 9. Okay, last one. This one I'll solve since I'm here, since it's pretty quick. There's no common factors. 3 and 8 don't have any common factors. So if the first two terms have no common factors, then nothing is going to have common factors. So my sum is 8, and 3 times 24 is 72. Now, the reason I want to show you guys this one is 72, you can split into 9 times 8. So just starting with 9 times 8 as a factor, because I know my 9 times tables. 9 times 8 gives us a sum, if we add those two numbers together, of 17. And since this is positive, this is positive, this is going to be positive, this is going to be positive, this question, again, we're looking for a sum. So 17 is a lot bigger than the 8 I'm looking for. And no matter which way I go, if I bring my 8 down to a 4, then that means that I need to double my 9 to 18. And that gives me a sum of 22, which is bigger. If I go in the other direction, and I reduce my 9 down to a 3, then I need to triple 8 to get 24, which gives me 27, which is bigger. And in fact, because 8 and 9 are really close to each other, they're as close to square root 72 as you can get. If you did square root 72, you'd get 8 point something, which is between 8 and 9, which means that this 17 is the smallest possible sum and the smallest possible difference. If we were doing a So this is our sum. If we were trying to do a difference for some reason, if it was a different factoring question, the smallest difference you could get would be plus or minus 1. And that's the smallest number you can get, because these are the factors that are closest together. And so I know that there's no possible numbers that will fit here. There's no possible number that will fit here. So this one does not factor.